The exhibition is called Regeneration, Long Island's History of Ecological Art and Care. And it's a topic that's really dear to my heart, and you'll find out more about that during our talk. And so when we started talking about an exhibition on ecology, we decided to focus it on this very place here, the East End of Long Island, because while we believe that environmental issues are global, the actions have to be local. So we invited 11 artists, and they are very intergenerational, so it's a group, the youngest I think are in their 30s, the oldest is 93, and all of them have really strong ties to Long Island and this on the East End. And they all approach issues of rising sea levels, depleted natural habitats, and ocean pollution from a place of curiosity, hope, and shared responsibility. And I think you will find that out in this conversation. I would like to mention the other artists in the exhibition. Scott Bludorn, Jeremy Dennis, I think he's here today, Sasha Fishman, Maya Lin, Tucker Marder, Mamoon Nakumanu, Cindy Pease Rowe, Sarah Seastream, Alan Sunfest, and Michelle Stewart. And we have a whole series of programs connected to this exhibition. A couple of weeks ago, we had a conversation with the Rauschenberg Foundation and several of the artists. And we felt very honored that the Rauschenberg Foundation felt inspired by this project and actually supported it. So I would like to also mention other supporters of this particular Randi's project. First and foremost, Lois Whitman and Elliot Hess, thank you so much for making this possible. It absolutely would not have been possible without your help. So big round of applause, thank you. We also got support by the Robert David Lyon Gardiner Foundation. They really focused on Long Island. And Sandy and Stephen Pearlbinder, thank you also so much for always supporting these wonderful projects and being here. The exhibition really was mostly curated, I would say, by Scout Hutchinson, my colleague. She is the Flag Art Foundation Associate Curator here at the Parrish, and I think you really knocked it out of the park, Scout. Yes. What else is there to say? I think let's get started, and we will find out more about Randi and Juli as we go along. And they will each be doing a presentation, and then we'll have a conversation. So Juli and Randi, please join me. So I'd like to invite Randi to start with her presentation.
Hi, y'all. Okay. Thank you so much for being here on this rainy Saturday, and I hope that if you're in the area and you want to come back and see the work when it's a blue sky, orange and blue is a great color combination. But I'm here to introduce you a little bit to my artist practice, which is a blend of art, science, ecology, restoration. I've worked a lot with scientists globally, specifically in coral restoration, but just ecosystems restoration in general. Here's a recent image of myself in Indonesia, in Bira, and we were on our house reef taking care of the outplanted corals. This is also recently in Indonesia, this past January when I was doing my dive masters. This contraption is called, it's for benthic surveys. So basically we go at different depths and we take a series of images of the benthic zones, starting at 20 meters, 15 meters, 10 meters, to sort of understand what's happening in our changing ecology, whether certain areas are really impacted by fishing and trawling, and to sort of see like, okay, what is growing at these different depths. Here's a little bit of, I bought an underwater camera last year too. I do a lot of work that is inspired by nature, both in my giant sculptural practice, but also in my ceramic practice. This is a piece that I made right after COVID really hit in 2021. It's currently at the Adirondack History Museum in upstate New York, and it's called Blue is the Atmospheric Refraction I See You Through. I don't know if anybody is a big fan of Maggie Nelson and has read her tiny book called Bluettes, but it's this very poetic book that is really reminiscing on the color blue, distance, longing, subjectivity. What is it like to be an individual human in this collective world? So I kind of created this larger piece where you can go up with two people and you're kind of meeting each other sort of at a distance. And it was one of my first larger outdoor works. This work brought me for the first time to the East End. This is a solo exhibition that I did in Amagansett. If you can kind of see the architecture and if you're familiar with the area, this is actually the gallery is a converted potato barn. And this work is really showcasing a lot of my ceramic pieces. These are a little bit of details. You can see the coral formations and the polyps and the colors. These are also based on sort of my writings and sort of musings about when I'm working with ocean scientists. Here are some of the pieces that were outside. So here's another, my favorite jelly, the Tinophora, which maybe you can talk about a little bit. And a larger shell. The last on your right, is a home that was in South Florida. That was the beautiful dome houses that this tech oil billionaire was like, I'm going to build dome houses on the beach, and then it eventually washed away. So it's sort of this relationship, humans' relationship to the ocean, how we want to be near it, how we want to conquer it, how we want to change its landscape, and yet she will always win. So this is a recent piece called The Sea Within Us. I just installed it about a month and a half ago in Indonesia. And where I was doing my dive masters, there was a lot of boat building happening, and I saw this really beautiful wood called ironwood. It's like the densest, darkest wood that they use for the hulls of these insanely beautiful Phoenici ships. Here are some details of that. So if you ever want to go diving in the middle of nowhere in Indonesia, this place is called Blue Planet. You can find it on my website. And here's a picture of some of the coral polyps. And I wanted to show you, this was found, I found it at the Okinawa Aquarium. And if you look at the architecture of this image on the right, this is what an individual coral polyp sort of looks like when it's spliced open. And this is the work at the Parrish. So I'm interested in looking at these sort of micro structures and blowing them up past human scale and sort of inverting the ontology of like human and nature. So I really hope that you will enjoy the work outside. Thank you so much.
Thank you, Randi. And I want to add, well, the title of the work are Recycled Coral Polyps, right? And it is modeled after a coral polyp. It's just hugely enlarged. And I first saw this work at Socrates Sculpture Park in 2022 when they commissioned you to do it there, and I was so blown away by it. And I was dreaming that maybe one day I'll be able to bring it here, and voila, so here we are. So thank you, Randi. And trust me, I've seen Randi working away for 2 weeks. You know, I can hardly believe that you did all this with your team, amazing team. And I would say that's dedication. So thank you, Randi. Julie, let's hear from you.
So I am actually a scientist and a science writer. I got my PhD in satellite imagery of the ocean, and then I fell out of the academic path and became really a science writer. And I've written a few books. The first one was about jellyfish. The next one was about coral, which is when Randi and I got in touch. And then after my coral book came out, which is called Life on the Rocks, This guy from Honduras reached out to me. He had read the book, and he said, I have this healthy coral reef, and you have to come see it. And I said, well, that's impossible, because the coral in the world are doing really, really poorly right now. And the reason that they're doing really poorly is because we've warmed up our planet. And although actually what I did for my PhD was try to figure out how much carbon dioxide was creating photosynthesis. So carbon dioxide plus water plus light is photosynthesis, right? And that makes sugar. And so the phytoplankton in the ocean, that's what they do. That's their business. But actually, coral also have this connection. These are polyps. We're talking a lot about polyps today. So this is a colony of coral. And coral are made up of these polyps, of which one giant one is now sitting outside the museum, which is amazing. But coral are all connected together. All these individual, flower-shaped things are individual polyps, and they are connected by their tissues. They share digestion with each other. But they're basically a jellyfish upside down, connected together. They're really like water. They're very, they only actually have 2 tissue layers. But what they do have that makes them so magical is phytoplankton that live inside of their tissues. So this is the close-up of a coral polyp, and you can see right through its tissue. It's so thin. But those golden orbs right there, those are actually phytoplankton, like single-celled algae that have decided to live inside of the coral's body. And they do photosynthesis. And they make sugar, just like all photosynthesis does, and they feed 90% of that sugar to the coral animal. And that's the coral animal's superpower. And that's how it has enough energy to make limestone sculptures that are its skeleton and make the reefs, the great coral reefs of the world, which support 1/4 of all the animals that live in the ocean. So it's, even though coral reefs take up less than 1% of the ocean space, it's like this disproportionate impact on our seas and life in the ocean. But the problem is that this symbiosis, this incredible symbiosis, is super, super sensitive to heat. And as we've added carbon dioxide to our atmosphere, we've heated it up, 90% of that heat has gone into the ocean. And that heat, when the temperature of the ocean rises by about 2 degrees Celsius for like a month or so, we don't exactly know why, but those algae are like, see ya, I'm hitting the high road, and they leave. The symbiosis falls apart. The coral are what is called bleached because they take their color with them. The coral are then white. They also aren't getting the sugar that they need to survive. And so the coral are starving. And around our planet today, half the corals in the world have died already from coral bleaching. In the Caribbean, it's even worse. It's like 80%. And in Florida, in the Florida Reef Tract, we have between 1% and 2% of our historic coral levels left. So the situation is pretty dire. And this is what a lot of Caribbean reefs look like now. So that's me in the Dominican Republic. You can see stuff growing on the floor. Those are mostly all soft corals. There's really no hard coral left here. And so when this guy from Honduras reached out to me and he said, I've got this healthy coral reef, I was like, impossible. And he's like, no, come see it. So I went down there, and it was like, what is going on here? The place is full of hard coral. It looks like diving into the 1970s. And so the third picture on my very first slide was called Tela Coral. This place is called Tela, Honduras, and I've started a nonprofit to try to understand why these corals are surviving when corals everywhere else in the Caribbean are just not. And so I actually want to draw your attention to that one up on the top left. That's called elkhorn coral. It used to be the most abundant coral in the Caribbean. It was declared functionally extinct in Florida in November. In Tela, you can see there's jungles, massive jungles of it left. And we don't know why. But we did get the attention of the University of Miami, who came down to Tella, and they took some of these elkhorns back to Florida and just got super lucky because they happened to spawn just a month later. And so they were able to make babies with Florida elkhorn that were in aquaria. And those babies are called Flandurans. And it's really hard. Like, there's a lot of problems with getting permission to move corals around. They're animals, they're endangered, all kinds of things. But we got permission last June for the first time in the world to plant some Flandurans, so non-native genotypes, off of Key Biscayne. And that was the day we planted them there. And that umbrella thing is to just keep the predators away for a little while till they get established. And then that was about 8 months later. And I just got word, the top and the bottom ones are the Flandurans, that one of the Florida ones got eaten away. But I just got word like 2 days ago that all the Flandurans have survived the whole year. So it's like 50 babies are still out there. And they're doing great. So it's very, very exciting. But what we also realized is that we need to create a marine lab in Honduras so that not just Florida is taking care of these really precious corals, but that we are in Honduras as well. So the nonprofit was able to purchase this land, and we're going to build the first marine lab in Honduras there. And the way we're raising money for it is through this amazing partnership, and it's an art partnership as well. So this guy, Chad Cannon, read my book about corals, and he reached out to me and he said, hey, I've been working on this concert called Music for the Ocean, and I need a call to action. And I said, I have one for you. Help me raise money for this marine biology lab. And so we've been touring, and we're doing a show on Wednesday night at Symphony Space in New York at 7 o'clock, and you're all invited. Please come. And I think I'm going to maybe try to play you, if I can, up in the top right, it's a little excerpt. Well, trust me, it's such beautiful music. It has, that's some of the animation, so it's violin, piano. We're actually having a guest harp and cellist and a second violinist play with us. And it's animation from Studio Ghibli. And and Chad and Hui, the concert pianists, both went to Juilliard and met there. And it is a stunning show. And it's the kind of show that, like, after people see it, they want to tell all their friends. So anyway, that's my little pitch, and
I will be there.
Yes,
so
Randy will be there.
Please come.
And it's going to be great. So that's a little bit about me.
Thank you both. Maybe we can get, thank you. Maybe we can play the video towards the end if we can get that going. But this is a real story of hope, Julie. I mean, it's amazing. And I want to get into that a little bit deeper in a moment. But what I hear from both of you is that there's really an amazing interconnectedness amongst everything that happens in nature. And we have to recognize that we are part of it as humans. And I think oftentimes, it is also about us being interconnected and how we tell the story and how we can collaborate on making change. And I'm just curious about how both of you made a decision in your life of which direction you wanted to go. Like Randy, you wanted to be an artist, but your work is very much based in science. And you decided to become a science writer, so it's also about telling the story. So I'm just curious to hear a bit more about what prompted you to go in that direction for each of you, and then how you met and how you collaborated.
That's a really good question. I wanted to be a scientist when I was growing up. I actually wanted to be a biologist, so I went to school for marine biology in my first year, and I was also taking a bunch of art classes. I think I did want to be an artist, but my family was like, there's no way you can make that into a career. You're going to be broke. I am broke, but I love my life. And now I am working as an artist, an architect, with scientists and with the reefs that I love. I mean, I first dove in the Florida Keys when I was 8, spent a lot of time there through my teenage years, and then moved to Berlin after I finished art school. Spent time away, and then went back to Florida and was like, wow, this looks like a graveyard. And that's when I went, and this was actually during my time at the Yale School of Art doing my master's. And I, at the time, was working a lot with the cognitive science labs there, thinking about neurons and interconnectivity and how we sort of can envision and how we understand perception and phenomenology. And I think there's a through line of something that is what I like kind of put under a larger umbrella as like the rhizomatic, like the web, the tree, the coral. And there's something about wanting to infuse that in a lot of the work that I do, not only sculpturally, but just as a human in the world, to connect people, to foster deeper relationships, and move away from this sort of individualized thinking that is happening in our capitalist society. And I think this year I've worked with scientists so much, just hands-on in the field, and have been having a lot of moments of like, wow, somehow I've merged my two childhood dreams. Like, how lucky am I?
But I feel like it also takes a real sensibility, an artist's sensibility, to translate what you see or what you know into beautiful artwork. And I feel like that's what you're really able to do. And I mean, a perfect example is the sculpture outside. I mean, how did you get that idea of creating this huge sculpture that resembles a polyp, a coral polyp, and inviting people to sit inside and also to listen to your podcast? So it's a whole thing, and I think that's what drew me to it from the very beginning. And I've also been listening to your podcast, Coralescence. It's a beautiful title, and I encourage everybody to, when we get rid of this sound, to listen to the podcast. There's a QR code near the sculpture, and really encourage you to listen, because Randi did some special interviews out here on the East End, and it was really fascinating to hear what's happening here, you know, and maybe we'll get a little bit deeper into that in a moment. Another thing I wanted to call out is Randi's drawings that are in the exhibition, because you had a residency in the Orient Point Lighthouse, and maybe you can talk a little bit about that experience. And these drawings are really beautiful.
Well, when I was brought out to the East End 2 summers ago for a couple months, I met an incredible artist named Randy Palumbo, who is out here as well. And he was like, oh, I own the Orient Point Lighthouse, and we have residencies, artist residencies. And I was like, okay, well, is there running water? Like, how do you feed yourself? How do you get there? You have to bring everything in by boat. There's a desalination tank there. There's also, there is a little bit of Wi-Fi and electricity, but it's kind of like, you know, so we really lived, my collaborator, Beatrice Chachamovitz, and I boated in and stayed there for a week, looking at all of the different, like, plankton and fish, and just, we were just doing a lot of, like, species drawings, but not necessarily through, like, okay, it needs to be a perfect scientific rendering, but taking this sort of essence of these creatures, and it was a really special, it was a really special time to be there, yeah.
It shows in your drawings, it really does. I think we might be ready to see the concert.
Okay, just play like 30 seconds. This is sort of the showstopper, so.
Something's happening.
flock of massive tunas that were just feeding. And one of them came by like 5 feet away from me. And I think going back to what you were saying, Corinne, about the power of art and music to transport you. I mean, not all of y'all are divers. I'd hope that you'd go into the ocean, maybe like snorkeling, but for those who can't, we want to show how beautiful and amazing these ecosystems are and how important they are. So I felt that a lot. I was like,
Yeah, it's pretty cool. I think one of the most amazing things and the most important thing about art and science collaborating is that, and I said this to Corinne in our kind of emails before, but you know, if data were enough, we would not have a problem with climate change. You know, like the data is there. What we don't have is sort of the feeling and the activation to do something about it. And that's where we really need art, because I think, you know, sitting inside of a coral polyp, you have a feeling of the world as a sort of an immersive sense of what it must be like to be a plankton, really. And that's like a feeling you can't get through data. Mm-hmm. It's impossible, right? You can only do it through art, and that's why we really need art, and that's such a gift.
Yeah, that's absolutely right. And I have a little story to that, because some 20 years ago, I co-founded an organization on art and climate change when practically nobody was talking about that except for Al Gore. And we were invited to do an exhibition at the 2009 Copenhagen United Nations Climate Change Conference. And so we rented a space in the center of Copenhagen, and we invited all these artists. And we invited UN delegates to come and see the show. And one of them said, "Now I finally understand what it's all about." And that's exactly it. When you read a science report, you can't imagine what's really going on. It's really when you have it in front of you, when you feel it. And I think only art can do that, you know? And it's not just data visualization. It's really creating something unique that takes you inside of that particular element. I'm really curious, Julie, about this incredible discovery that you've basically witnessed about this coral restoration that you're part of. How do you think you can make this more known, or how can you take this to the next level, and how can art be a part of that?
Yeah, so it's actually not a restoration. It's just there. It just exists, and we don't know why. And actually, this part of Honduras is exactly where the banana plantations first were put in to Central America. In 1905, 1910, the first plantations went in there. So it's been polluted by runoff from fertilizer for over 100 years.
How is that possible that they're still alive, though? Because we've had, I mean, in the podcast, particularly to the East End, I talk about with Pete Topping, like a baykeeper here. He's like, yeah, there's so much water runoff, pollution that has completely changed the bays. Like, how are they?
So we don't know is the answer. So no one looked for this in this bay for coral until about 16 years ago, because no one expected them to be there, because it has had a human impact for so long. There's also a lot of river sediment there, and it's possible that the coral there have had a longer time to adapt to human impacts. So the rest of the Caribbean kind of got industrialized in the 50s and 60s, and that's when it really started getting polluted. These guys had 50 extra years to figure out how to survive a more polluted environment. So maybe just having that extra time to adapt is part of it. The sediments actually may, in today's world, be acting like an umbrella, shading the coral. And so something that in the past was seen as problematic because it limited the access to sunlight, which the corals need for the algae that live inside of them to photosynthesize. Today, maybe it's a benefit to have some shade, some protection, so that it keeps it a little bit, you know, there's evidence that it's not just heat, but it's also light that causes the bleaching.
Hence why it's important to build the marine lab there, to sort of have scientists on the ground, in the field, understanding what's happening.
And this isn't published yet, so don't go spreading it around. But the University of Miami scientists have figured out that the species of algae that has formed a symbiosis with the coral in this place in Honduras are a different species, a more thermotolerant species called Durstinium, which you might have heard. Yeah. So they're the only wild corals that we know of in the Caribbean that are have formed this new symbiosis. So that could be part of it too. The Flandurans also have this this more thermotolerant symbiont. So we don't know if it'll last, if the Flandurans will kick it out and go back to the one that's less thermotolerant. We don't know, but yeah, we have to figure out what's going on. And then there's one more thing there. There's this strange sand. It's black, and I had it analyzed, and it's 23% titanium. And it turns out titanium oxide in the presence of ultraviolet light forms basically hydrogen peroxide, which is an antiseptic. And so it's possible that in the springtime, after there's been like kind of a wash through with this titanium sand, the sun comes out and they get a little like pathogen load decrease by having hydrogen peroxide, these oxygen radicals in the water. Wow. So we have a lot of hypotheses. We don't really know what's going on, but yeah, it's a really exciting place.
That is really fascinating. Randi, I listened to your podcast with Pete Topping, and also really interesting because Pete is from a family that dates back, to the 16th century here on the East End, and he talks about changes in the ecosystem that obviously also affects cultural change. And we have several artists in this exhibition that talk about that, like Scott Bluedorn, also Jeremy Dennis and the Shinnecock kelp farmers, obviously going way back with the Shinnecock culture of being stewards of the environment and how that has changed and how climate change and pollution, nitrogen pollution here has affected changes in the environment, but it also affects culture. And maybe, Randi, can you talk a little bit about what you found out by talking to him, what's happening here on the East End?
Sure, yeah, that's a really good introduction. We were particularly talking about the sort of Bayside area and how that was affected by different types of runoff. And what I was really struck by was Pete speaking about growing up, watching this ecosystem change, and then having his kids go out on the boat, finally seeing cetaceans, dolphins, and that sort of ecosystem being restored, and him being like, wow, I can't believe that they're back, and the kids being like, okay, well, what's the excitement here? You're welcome to listen to the podcast for more information on like different types of ways that you can help and join in on the ecology here through the Peconic Baykeeper for monitoring. But it was a great conversation.
I can imagine. I'm curious about how you see future collaborations between scientists and artists taking shape. What is your hope? How do you see that being supported or not being supported? What would it take? And, for example, how have you collaborated together, or would you see yourself collaborating? And also, what do you need from the world around you, support, money, or organizations and so forth? What does it take, in your opinion, to do that?
I don't know. The world keeps clashing Randi and myself together. I don't know. It's very strange. But we met through a mutual friend.
I met through your book, really. A mutual friend sent me your book. Oh. And it was signed. Oh. And then I read it and I was like, I have to talk to this person.
And then we talked. And then it turned out that Randi's opening was just, 3 days before this Symphony Space thing I was doing. And now it turns out we're going to be in Japan at the same time this summer.
But you also supported my project with my collaborator Beatriz as well, on the beach with coral.
Yeah. So I don't know. It seems something is going to happen.
So it's like you're connected like the corals.
Yes, yeah, there's this like the community. But yeah, I think, one of the things I think we haven't said yet, which is sort of a theme that I feel very strongly about, is that, the oceans in general have an invisibility problem because we are terrestrial, right? Like, we live up here on land. It's really hard for us to visit the ocean. Even on scuba, you get an hour, hour and 15 minutes at a time. And so it's just a difficult world for us to connect with. And if you look at sort of the cultural ways we describe the ocean, it's like the depths, the abyss, the dark, And if you think about the heavens and the stars and celestial, we have sort of this idea that space is where we want to go, but we live here on this planet with our seas. And I think there's a disconnect there that I think we really need to address. And even if you look at funding, space funding gets like 250 times more, and like, forget about the budget that's trying to get passed right now, which is like Xing out the entire Office of Ocean Research. But, space funding is always like 250 times more than ocean funding. And so there's a real problem with the invisibility of the ocean in our psyche and in, also where we spend money.
I think that's a really good point because it's invisible, it's dark and mysterious, right? I don't know if you both have heard of TBA 21. I'm sure you have. So that's an organization that was founded by Francesca von Habsburg, and a very prominent organization, an academy where they have artists and scientists collaborate and they go on these expeditions. They had, for example, artists like Joan Jonas. So, they get the attention that they need for these kind of research projects. Also, another thing that I just found out is now, for example, MoMA has hired an environmental curator. So, I think there's more and more awareness in various areas to really bring that to the fore and show people what's really going on and to start change. I wanted to, before opening it up to the public, I want to ask both of you what gives you hope in your work.
Coral gives me hope, even though it's disappearing in certain spaces and many spaces. But I think the first sort of philosophical connection that I have with coral is thinking about how all of these individual coral polyps, they're individual animals that are working together in a colony, in symbiosis with, like, the zooxanthellae. And I think that there's something that we could learn from those corals. And I think about that almost daily in my relationship with humans and friends and people that I meet. And it's something that I would like to just share with you all through the sculpture. So coral gives me hope, even though I see a lot of it dying throughout the world. And also scientists who are working specifically in restoration. I have been, over the years, collecting stories of restoration, not only from coral, but sunflower sea stars and pycnopodia. And there's so many people who are working towards restoring these ecosystems that really need our help. So that's what gives me hope.
Thank you, Randi. Julie?
Well, definitely Tella's corals give me hope. The fact that they're showing this incredible resilience, I do get a lot of hope from that. But I think I really get hope from moments like this. Like, you guys are all here to talk about the ocean, to talk about art and connection, and what kind of world we could hopefully have. There seems to be an emergent sort of energy around the fact that we need to take better care of our planet, and I feel that when I come to events like this, and I feel a lot of hope from that.
Thank you, Julie. And I feel that too, and I feel it also through the response that we have for this exhibition. People are really curious, they want to know, and engage. So I'd like to open this up to the audience. If anybody has any questions for Randi or Juli.
Oh, you're welcome. Thank you so much.
There's a question there.
We know what humankind is doing to the environment, the climate. We know what the climate is doing to water. But I guess my grade school question is there any predatory relationship between sea creatures and coral?
Predatory relationship between sea creatures and coral. Well, if you remember the small coral fragment that had the sort of umbrella over it, parrotfish are fish that eat coral and then they excrete it out, and that's really what becomes the sand that we step on. So there's a lot of natural, normal predators to coral that have been there for thousands of years.
Yeah, and there's like fireworms. There's, the fireworms can do real damage. But lots of animals will pluck at corals. Corals, though, are first cousins to jellyfish. So they do have stinging cells, just like jellyfish do. So then they can fire those off and defend themselves. Also, coral are pretty competitive with each other. Mm-hmm. And if they get too close to each other, they have like special extra long stinging cells that they can fire to keep someone from getting in their territory. So it's a busy world down there. There's a lot of, stuff happening.
A lot of stories there. Any other questions? There's one back there.
Hi, thank you so much for the talk. It was so interesting. I'm wondering if you have found any uses for emergent technology in your work, whether that's like AI or new kind of like microphones or video cameras, or if you plan on exploring those technologies or if you already are.
I would love to collaborate with somebody who knows those technologies better than I do, because I can barely work a computer. I am working on a series of videos coming up. I'll be doing a year-long fellowship at Okinawa Institute of Science and Technology. And we will be taking long underwater videos of the changing benthic regions and probably using some sort of like AI tool to sort of map that change, as well as when it's rainy season and the sediments come and how those, it's kind of wild when the soil in Okinawa is really like rich and red and full of iron, and when the rain comes, the whole sort of coastal area looks like this blood red, and it kind of covers all of the corals, and much of that was done because so much of that area was turned into farming, which then kind of uproots all of the trees that are holding the sediment. So I'm open to working with emergent technologies in a sense, but I'm definitely not somebody who is an artist completely savvy in tech, although I have many friends who I can poke when I need help.
We are actually doing we're going on a trip. You're also invited to Tella if you wanted to come. We're going to try to find the coral spawn. The coral spawn once a year after the full moon, sort of this big romantic thing. And we're actually bringing some hydrophone scientists with us to try to listen. When the coral spawn, it's like eggs are just in the water, so it's like buffet time. And it gets really, really noisy. All these animals you never see show up to eat the eggs. And it's like slapping lips. It's just very loud. So we're going to try to record with the hydrophone to find out when the coral are spawning.
That's incredible. Yeah. Do you think that they could decipher the noise of different species?
So there's a lot of work being done on that. And one of the really interesting things is that coral make they spawn their little eggs and sperm and
they
fertilize.
look like Dippin' Dots, if you can imagine, in the water.
And then the larvae look like a Tic Tac. which is covered in cilia. And so then it has to swim back to the reef. And how does this little tic-tac make its way to a coral reef? Like, how does it do that? Turns out it can hear a healthy reef. And so one of the ways they're trying to bolster coral larvae to settle on the reef is by playing the sounds of a healthy reef to trick them.
So you're telling me that this tiny larvae can hear, which is incredible.
Can't see. It doesn't have any visual.
But this is like what I love about these creatures. It's like there's so many creatures that have different ways of seeing, hearing that are so different from us. Like we think, oh, jellyfish, they can't see, but they have photoreceptors. They understand up and down. It's pretty incredible that type of perception.
Yeah, they're more sophisticated than we usually realize.
Steve.
Yes, there's habitat that is opening up, but the hard corals haven't been able to exploit it. They grow too slowly. But we're talking, Randi's done a lot more restoration than I have actually, where you actually take coral and plant them in these opened up areas.
That's a good question. So in the Florida reef tract, there's a lot of, after the hard corals died, and if you think about hard corals, you think about the architects of the oceans. These are what's creating all of the structures. And then you have soft corals. So there are areas that the hard corals are turned into rubble, and then these soft, beautiful Gorgonian sea fans are purple and pinks, and they're everywhere, and they're really gorgeous. But the issue with those soft corals coming in where hard corals were, hard corals in particular, they absorb so much wave energy. So especially during hurricane season, once that area is destroyed, the hurricane and the pressure of all of that force just goes directly on land. So yes, in a sense, it is opening it up. These ecosystems, as they die, are opening it to new types of species to grow. But we're really seeing the impacts, especially during hurricane season, and sort of seeing, like last year, really, we saw like hurricanes move like all the way up to the Carolinas and even impact New York State. I hope that maybe answers a little bit of your question, sort of.
There is a possibility for coral to evolve, and we think they can evolve or coral geneticists think they can evolve rather quickly. However, they grow very slowly. So that, and their generation time, they spawn once a year. So that you don't get a lot of generations. You get one per year. And the corals in the Caribbean are really, really, really bad at reproducing. They're the ones that I said are now extinct in Florida, their reproduction rates are like 1,000 times less than animals of the same species, same genus in the Pacific Ocean. So there's actually an idea on the table to move some of these faster reproducers from the Pacific into the Caribbean. It's super, super controversial. That the answer is that a quarter, like something like 830, I mean, this is a number from the scientific literature, so you have to take it with plus and minus, but something like 1 million species of animals live on coral reefs. And so if the coral reefs go away, we lose 1 million species from our planet as well. So half the corals have died. I don't know how many species have died.
Basically the consequences of that, of coral dying, right?
Yeah, I mean, we lose a huge amount of biodiversity on our planet, and that's on us. It's not, because we still have half the coral.
Well, one last question, Mark.
Yeah, I know there are some technologies that are being used to re-establish coral reefs in some areas. Like I think there's one that's called BioRock, which you might be familiar with in Indonesia, that they build underwater metal scaffolding and then I think put some low voltage current through it, which, yeah, anyways, and I just wondered if you had any experience with how effective these are and some other technologies.
I have heard of BioRock, but I've never worked with it myself. I think the types of restoration that I've done are very much like either corals that have been grown in labs on land, working with this one organization called Coral Vita. They're in a couple different areas, but I was working with them on Grand Bahama, and so they're growing the coral fragments on land in these kind of like aquaponic structures and then outplanting them. And that system of outplanting is kind of using any sort of type of glue substrate, and then we're like gluing the corals onto like dead areas of the reef. Yeah, I can't speak too much to the method that you said, because I've never worked with it before, but I think it's important to be trying a lot of different types of technologies at this moment, because it kind of needs to be all hands on deck. Because I think the biggest thing is, if you think about our ecosystem as a giant spider web, and you pull one string of it, that entire web sort of collapses. So corals are really this keystone species that are keeping our food alive. Like, it will somehow impact our fishing industries, and it has. It will impact the cetaceans, and it will impact our hurricanes, as we have seen over the years. So whether you're getting in the water or not, this issue is directly impacting you at home. So.
Well, I want to thank Randi and Juli for showing us the work that you do, and honestly, your work gives me a lot of hope. So thank you so much, and please join us for a reception outside.
Thank you.